Amrita Vishwa Vidyapeetham, Coimbatore, India. He has completed his PhD in Neural Machine Translation from Amrita Vishwa Vidyapeetham. His thesis was on embedding linguistic features for improving neural machine translation from English to Malayalam and building deep learning based NLP tools for Malayalam. His current research focus is on natural language processing and deep learning. Apart from Malayalam, he has also developed deep learning based NLP tools for various Indian languages. He has also worked on applying kernel methods and explicit feature mapping algorithms in various domains at Amrita Vishwa Vidyapeetham. I welcome you, sir, to take the session.
Good morning. Thank you for inviting me for this conference. So today's talk is related to natural language processing, recent trends and research avenues. So I am Premjit. I am from Amrita University, Coimbatore campus. So to start with, we'll see the definition of NLP. As you all know, natural language processing is the computational processing of the languages. Basically, it is designed for improving the human-machine interaction. So this technology is the backbone of all the recent algorithms. If you consider the large language models, the recent boom in the AI area. So the research started with natural language processing. Okay. Basically, NLP in general helps the machines to understand the language, understand the context, understand the meaning of the sentences, not exactly the meaning, but somehow the NLP algorithms helps to understand the meaning of the words, meaning of the sentences, how words are connected in a sentence. And it also helps the machines to generate new text based on the context. So how can we use natural language processing for different applications? The first one is NLU, which is natural language understanding. Natural language understanding is nothing but the understanding of the language, which means that generating some representations for the given text. The text can be a character or a word or a sequence of words, or in general, you can consider as a paragraph or a sentence or a document itself. Nowadays, it is even possible to generate one vector representations for a huge documents. Okay. We assume that this representation contain the whole meaning of the sentence or the document. So that is the purpose of natural language understanding. So NLP, uh, in recent days also, people are trying to build models for converting the text into numerical representations. Okay, so there are two main challenges with text analysis. One challenge is basically if you analyze the text using machines, we have to convert the text into some numerical for representations or embeddings. Okay, so when you consider the text analysis, there are two major challenges. One challenge is how do we represent the meaning of a word using numbers. Second one is if you see the text data, if you see the words, each word will be having different number of characters in it. If you see a sentence, each sentence can have different number of words in it. So we can say that the text data is length invariant, or there is varying length sequence we have in text analysis. Okay, so how do we deal with these kind of data? So if you consider the image data or signal data, other signal processing data, all are fixed length data. Okay, all are having some kind of numerical representations. But in the case of text, the way to convert the text into numerical representations and the way to deal with the varying length sequence are challenging. So the NLP algorithms are basically try to deal with these two things. The algorithms like recurrent neural networks, LSTM, transformers, these algorithms are basically used for uh, learning this varying length information from the text data. And the algorithms like Word2Vec, FastText, Glow, Elmo, Bird, these are basically used for learning the semantics from the text data or the word meanings from the text data. Nowadays, we have only one algorithm which is capable of doing both tasks. Like there is a transformer-based algorithm which can actually deal with the varying length of sequence as well as can capture the meaning of the words and convert the words into numerical representations. Previously, we had different algorithms for all these tasks. Nowadays, we have only one model, not one model, one algorithm using which we can define different type of models to learn these two information from the data. So basically, understanding phase of the NLP pipeline helps the model to learn the representations or embeddings from the data. So to do that, we may have to consider the semantics, not just semantics, but the syntax also. So the word to vec, the fast text, all these algorithms are learning the semantics from the data. But when you see the implementation of this algorithm, they are actually considering the syntax also into account to generate the embeddings. For example, the algorithm which is used for training the word to vec algorithm, skip gram based algorithms, or continuous bag of words algorithm, they are actually predicting the middle word given the context words. Okay, so when you do that, you are actually identifying the words which can occur in between different context words. Okay, so basically they are they are learning some kind of syntactic information, not the exact syntactic representations, but some kind of syntactic knowledge is captured in the word to vec and fast text or all these algorithms. So when you see all the word embedding algorithms, they require some amount of syntactic knowledge as well as semantic knowledge to generate the embeddings for the words. Okay, so to do that, again, we had to consider the context also, the meanings of the surrounding words. If you want to predict the embeddings for the middle word, the concept that we have in transformers, self-attention. Okay, you are trying to generate the embedding for one word, okay, by considering the contribution of the other words to generate that embedding. So in all these cases, we have to consider the context. Context means the representations of the other words, surrounding words. Okay, so context, syntax, and semantics are very, very important in natural language understanding. Okay, second one is interpreting language context. So we have already discussed that one. So we have to decipher the context to interpret the language accurately, which means that we have to identify the words which can uh, come in the surrounding phases so that we can actually predict the appropriate words in a particular context. The reason is each word can have different meanings in different contexts. Okay, or else one word can have different meanings in different contexts. So identifying the proper word in a particular context with a proper meaning is challenging, and so that is easy for human beings because we have a lot of knowledge encoded in our DNA, but that is not easy for the computers. So to do that, we have to teach the computers all these techniques. Then the second phase of the natural language processing, generating human-like text, the algorithms or the tools that we use nowadays in our day-to-day life, ChatGPT or Gemini, these are actually generative models, text generation models. These models can generate poems, they can generate emails, they can write minutes of the meeting for you, they can prepare proposals for you, they can write assignments for you, they can do a lot of things. How do they do all these tasks? Based on one condition, one prompt that you give to the model. Based on the prompt, they start generating the future tokens or the text. So all these recent models are capable of generating human-like text. If you take the ChatGPT, a tool which is built on top of GPT 3.5 or GPT-4 or Gemini model, again, it is using the Gemini LLM by Google. So these models are basically generating the human-like text. There are other models as well, like Llama model is there. Then Phi 2 is yeah, Phi 2 is there. It is able to do that. T5 is there. A lot of LLM models are there to do the same kind of task. Okay, so nowadays these models are able to generate the text just like a human being. So these models are able to uh, pass the Turing test. But if you see the real implementation of these models in native regional languages, how can you, how much accuracy they are achieving in generating that text, natural text? So that is a big concern. So if you develop or if you try to generate text in Malayalam or Tamil or Telugu or Kannada using ChatGPT or Gemini, I don't think you will get a very fluent or adequate responses from these models. They have to learn these languages. Basically, these models are trained using English language. Majority of the language belong to these English and other European languages and Chinese also. You can actually, if you are a engineer, you can actually download the model and see how many tokens are available in each language. Okay, so now recently Google has released Gemma model, an open source model, which uses less than 1% of tokens from Indian languages. Okay, majority of the tokens belong to English and Chinese languages. Okay. So these are the two major steps related to NLP. NLP is language computational processing of the language, and NLU and NLG comes as part of the NLP. Okay, language understanding and language generation. So these two tasks you can actually observe in different tasks like machine translation, question answering, text summarization, etc. But when you consider the tasks like text classification or part of speech tagging or named entity recognition, you want to see the generation part of the NLP. You will be seeing the understanding part of the NLP only. So if you see the history of NLP, it started in the 1950s. So the initial research were in machine translation. Okay, so in the 1950s and 16s, people started developing machine translation models for translating uh, Russian and German script to English language. The initial days, people used the rule-based approaches, uh, rules written by the language expert and the program expert, okay, to translate a text in one language to another language. During the 1990s or at the end of this 1980s, the statistical approaches were implemented. Basically, again, these models were used for implementing machine translation, statistical machine translation. And statistical machine translation basically focused on the statistical properties captured from the training data, like using some simple conditional probability. The people were able to translate one sentence in one language to another language. Then it was extended to phrase-based translation. Instead of translating words in one language to another language, people started translating a sequence of words in one language to another language. So that continued till the mid of 2010s, the statistical machine translation approaches. So during those days, people started using statistical approaches for other other tasks also, like text classification, POS tagging. In all those tasks, people started using these statistical approaches, conditional random field, hidden Markov model, then other machine learning models like support vector machine, decision trees. So those algorithms were used for implementing all the NLP tasks. That time, the major challenge was in generating the representations. That problem is still uh, prevalent in the NLP area, like how do we represent the text in the most appropriate way. So that time in the 1990s or in the beginning of 2000s or in the entire 2000s, people are using this SVM kind of algorithms for classification tasks and CRF or HMM kind of algorithms for learning the sequential knowledge from the data. So that time we use some general features or general information from the data to represent words and sentences. So we had a bag of words, term frequency, inverse document frequency algorithms were to represent a sequence as vectors. But for representing the words as vectors, people used the number of characters in a word, the number of capital letters in a word, number of vowels in a word, the part of speech tag of the previous word and the next word. These were the information people generally used to represent a word. So that was too challenging because I don't think or no one actually believed these features because these features didn't extract any information, useful information like any meaning or other semantic information from the words. But there were no other choice other than this to convert the words into vectors. So in the 2000s, these machine learning algorithms were very prominent in classification tasks as well as in machine translation tasks. That time itself, the algorithms, deep learning algorithms were coming up, but in NLP domain, people rarely used these deep learning algorithms. But in the beginning of 2010s, people started using deep learning algorithms like RNN, LSTM, and other algorithms like GRU. So initially, these algorithms are proposed for implementing one task called language modeling. Language modeling is nothing but so in Google search engine and other domains you can find the language modeling concept. Language models are used for predicting the future tokens based on the past observations. Okay, so basically these deep learning algorithms were implemented for language modeling. A feed for a network-based language model was introduced in the beginning of 2010s. That was by Yoshua Bengio and his team. And that algorithm was replaced by RNN, LSTM, and GRU. And that actually paved the way to develop this transformer algorithm, which is again uh, basically implemented for machine translation, which has two parts, encoder and a decoder. Encoder's duty is to encode the input data, which is actually converting the input data into some vectors, and decoder's duty is to generate new text. Okay, so that algorithm was proposed in 2017, and after that, all the research is focused on that particular algorithm in NLP. Initially, that algorithm was used for machine translation and similar tasks. Later, people started using that algorithm for different other tasks like text classification, part of speech tagging, named entity recognition, dependency parsing. Now, all the tasks we can use this transformer-based algorithm. Then, other domain people started using this algorithm in their domain, like speech people are started using transformers. Image processing domain, we can find the application of transformers. Vision transformer is there. Clip models are there. Delay models are there. Then blip model is there. In speech, you can find audio GPT, speech GPT, whisper. So these models are, if you see, take any domain, you can find the application of the transformers in all the domains. So that actually revolutionized the NLP and AI research, okay, completely. So nowadays, I don't think any new research happened in the direction of algorithm development direction after the transformers development. Okay, so now in beginning of 2020s, people focused on previously these transformers on all these models were built for uni-model data. Like one model, one model can work with one data, one type of data. The data type can be text data or speech data or image data or video data. But now people focus on multi-model data, which means that a model can deal with the multiple modalities like images, speech, text simultaneously. So the Gemini model, which is built by Google, is a multi-model NLP. Sorry, multi-model large language model. The large language model, which can actually learn all these three modalities. So these LLMs, large language models, are basically built using the different components of transformer networks. So this is a brief history of NLP. So starting from the machine translation research to the large language models. So this is an old picture. It was taken 1 year back. So this shows the recent trends in large language models. Actually, the models available nowadays, we have a lot more large language models available. So in this picture, you can see till GPT-4. So after that, we have Gemini. Then Gemma is there. Okay. Then 5 models are there. Different models are coming up every day. So that is actually finding out the proper model for dealing with our task is again challenge for us. So recent trends in NLP, if you see the recent trends, I can say most people are working towards the pre-trained language models. Most people, in the sense, most giants in the industry are working towards the PLMs, pre-trained language models. For us, it is not that easy to train a large language model because you can see the statistics on the top and in the bottom also. 10,800 GPUs were used to train GPT-4 model, and Meta used 21,800s. So we cannot afford those many GPUs in our institution or organizations. But what we do is we focus on the transfer learning approach, where we can use the large language model for our downstream task. So, but the technological giants are focusing on building their own pre-trained large language models. Basically, they are focusing. Most of the companies are focusing on building multi-model large language models, multi-model, multilingual large language models, because the model can deal with the multiple modalities as well as multiple languages. So all the large language models previously built were multilingual models, which can learn multiple languages. But there is a bias towards the English language, because the majority of the tokens belong to English language. But if you see the current trend, I can say that people are focusing on multimodal large language models, multimodal, multilingual large language models. So pre-trained language building, pre-trained language models is one avenue where the technological giants are working towards. And people like us, the end users of the large language models are focusing on transfer learning paradigm, because we cannot afford to build the large language models by ourselves. So what we do is we take one publicly available large language models and use it for our task. So there are different techniques to use large language models or tasks, like prompting is there, RAG is there, retrieval, augmented generation techniques are there, then fine-tuning approaches are there. So depending upon the task and the data available to develop the model, or data available for the task, we can choose any of these methods, whether to go for prompting only, or whether to go for RAG, or whether to go for fine-tuning. So that is depending upon the developer who is using this large language model for developing different applications. Then multilingual NLP is again another task, even though the LLMs are available with the multilingual properties, but people are working towards fine tuning the large language models to deal with the multilingual NLP. There are different cases related to multilingual NLP or cross-lingual NLP. You can, if you search, you can also find the topics like multilingual embeddings or cross-lingual embeddings. So one idea related to multilingual NLP is like, so if you see the words like pen in English and its corresponding meaning in other languages, okay, the algorithms will be giving you different representations for one single word. Okay, if you change the language, you'll be getting a different representations. But for human beings, we have different languages and we can have different words to represent one entity like pen. But for computers, there is no such need. Like, you don't have to create different embeddings to represent one entity. You can go for only one representations. So using multilingual NLP and multilingual embedding concept and cross-lingual embedding concept, people are trying to develop only one embedding for one entity. So if you have pen, then if you take other language words to represent pen, all these words should have one single embedding. Okay, so that kind of research is also happening in one direction. Other one is the algorithm should be able to do the translation between multiple languages simultaneously without training a new model. So Google has introduced this concept in the first neural machine translation model, even before this large language model concept. So they used a concept called zero shot translation. So if you want to translate a sentence in one language, another language, even if you don't have that language pair in the corpus, training corpus, the algorithm is able to do that. So before this zero shot mechanism, what people did was like, there will be an intermediate language. So if you want to translate a sentence in Malayalam to Tamil, so the Malayalam sentence will be translated into English, and the English sentence again will be translated into Tamil. So that is how the translation happened previously before this Google's NMT model. Then Google NMT zero shot mechanism actually helped the model to avoid this the requirement of this intermediate language. Okay, nowadays the algorithm will be able to directly translate a sentence in one language, another language, even if there is no such translation pair in the training corpus. That is possible now. So that first approach was built in by Google. Then now all the language models, large language models, are utilizing this concept to implement their translation machines. So zero shot and few shot learning. So you can find this. This is another recent trend in NLP. You can find this term zero shot and few shot learning in two ways. One is zero shot and few shot prompting of the large language models. The other one is zero shot and few shot learning in the training phase of the model. So when you consider the training phase of the model, you can, as I said in the case of Google's neural machine translation, you can train a model even without seeing one single example. That is possible now. Okay. Or else if you have very limited amount of data with you, then if you want to train a neural network, then again that is possible. Few shot learning setup is available nowadays. Okay. In the case of LLM prompting, okay, zero shot prompting is there, few shot prompting is there. So prompting is basically utilized for changing the behavior of the large language models by giving some instructions and the prompts. For example, translate the sentence into English. Then I give a Malayalam sentence. So the Malayalam sentence is going to be the prompt, and the English sentence, sorry, the instruction. Translate the sentence into English. That is the instruction, and the Malayalam sentence is the prompt. So the algorithm, large language model, takes this prompt as the input, then it generates the translation in English. Okay. So in that phase, basically the algorithm is generating some tokens in the English. So it is a kind of a sequence. Okay. So we have given a Malayalam word sequence, and the algorithm will generate the corresponding translation in English. Okay. Only because of the instruction that we provide. Okay. If you don't give the instructions like that, then the algorithm will generate the tokens in Malayalam itself. Okay. Based on the instruction only, it is generating the translation in the English. So if you don't, I mean, if the model is not giving you the proper translation or proper, for example, if you take another example, like text classification, okay, you ask the model, or sentiment analysis, you ask the model to predict the sentiment of a text. Okay, the movie was good, and we expect the output in the form of positive or negative or neutral. Okay, if the model is not predicting the output properly, then we give some examples. Okay, if this is the input and the output should be in this format. Okay, so that is an example. So if you give some examples to the model to generate the output, then we can call it as few shot prompting. If you don't give any model, then we can consider it as zero shot prompting. Zero shot, one shot, few shot, etc. are there. Okay, so we go for this zero shot or few shot prompting when you don't have any amount of any training data with us. If you have some data for training the model or fine tune the model, then you can go for fine tuning the large language models or RAG based approaches. Okay, so if you don't have any more data, then directly go for prompting. Then ethics and bias mitigation is very, very important. I don't know how many of you have heard the news recently, like I don't remember the exact LLM people used. So some people trained LLM to recruit some people based on the resumes. These resumes were actually prepared using large language models. So they give the qualification, same experience, everything was the same, but random names. Okay, so when the prompt was given like recruit the people based on these resumes, then there was, I mean, the researchers identified that there was a bias in the recruitment policy, like the black people were, I mean, the percentage of black people recruited for that job was less compared to Asian and European people. So even though there is, the bias cannot be seen explicitly, but that bias is hidden inside the large language models. Basically, the model is built using the data that we feed into the internet. Okay, people, the people who train the large language models use the data available in the internet. So the data available in the internet are actually fed by the human beings like us. Okay, so we have a lot of bias and all these racial considerations in our mind. So that will be reflected in our data or the social media post or whatever we write in the internet. So that if people are using these data for building their models, then those models will be actually having the same kind of behavior. Okay, so earlier days, before this large language models, the Microsoft had to withdraw their TIE model. a conversational assistant because of the abusive language generated by this model. Then they came up with the Cortana. Nowadays, has some kind of better responses from the model. Okay, previously the GPT-2, GPT-1, all this model had a lot of issues related to the ethics and bias. Okay, this GPT-2 was actually proposed during the COVID time in the 2020s. That time, lot of discussion happened in the internet between the researchers, top researchers like Lakyun and Anima Anand Kumar, etc. They were talking about the problems of these GPT models because of the uh, racial contents generated by these models. Okay, so again, conversational AI advancements is the next recent trend in NLP. People are using these large language models and other tools for improving the human-machine interaction. So that is the major or ultimate goal of NLP, to improve the human-machine interaction. So if you take the robots, okay, so you should have some robots to which we can communicate as if we are communicating with human beings. So recently in US, one company called Moxie developed a robot called Moxie robot. So that robot is basically used for improving the social skills of kids. Okay, so the kids can actually interact with this robot. Then the robot will interact to the they interact and they can actually improve the social skills. The kids can improve the social skills. So if the parents are working and if they are not with the kids, then actually kids can utilize this Moxie robot for improving their skills, social skills. So those kind of boards you can expect in our uh, life also. Like our grandparents used to tell stories to us in the earlier time. So you can actually build these kind of robots to tell the stories to your kids in the same voice of your grandparents, how they speak, how they modify their tones and all while speaking. So actually you can build the robots or Moxie kind of robots in for our language also. And you can, there are a lot of um, opportunities available in that conversational AI case. Then the other recent trend in NLP is low resource language development. So basically, the all the models are biased towards the language, majority language, which is used for training the model. So one example I always take is the case of sentence space algorithm, which is built by Google. The sentence piece or word piece algorithm is used for tokenization in natural language processing. So if you see the implementation of sentence piece for Indian languages, the tokens generated by the sentence piece may not be that accurate. Yeah, these sentence piece algorithm is available for all the languages, majority of the languages, but most of the data used for training the model is English. So there is a bias towards the English language compared to other low resource languages. Okay, so low resource language learning is important. Low resource language, it can be the language or it can be the dialect of one language. Okay, or if you see the Kashmiri or Manipuri, Dogri, all those North Indian languages or languages like Pali or Maithili, these are low resource languages, and there are languages which do not have any scripts like Tulu. So if you want to build speech-based translation models for Tulu and other language, similar languages, you should consider their aspects also, how we can create models for those languages, how can we extract the useful informations, or how can we represent those languages in using computers. So bias is there in all the cases, okay, in the model development, in the data case also. So transformer architecture dominance after 2017, you cannot find any application of RNNs or LSTMs in NLP research. Everyone is focusing, moving towards the transform-based applications. So it can be used for text generation. It can be used for generating the embeddings. So transformer can do anything. Okay, so that's the reason people are focusing towards transformers. But what we can do is we can actually, there is a possibility to modify the transformer architectures. So hope you have heard about the Mamba model. Okay, so large language models. So transformers has the problem of dealing with the very large, very lengthy sequences. So the Mamba is able to do that. I mean, it is able to capture the contextual information from the lengthy sequences. But there are other transformer applications, like hierarchical transformers are there, which can learn the uh, lengthy context sequences or contextual informations uh, better than the normal transformers. Sparse transformers are there. So you can actually develop or come up with your own transformer models. You can modify the transformer architecture in such a way that it can solve the current research problems. So even though transformers are used for different applications, there are still options available to improve the model architecture. Then emotion and sentiment analysis is another task. So basically this is related to the speech data. It is not just related to the text data, because from the text we can actually capture the meaning of the words, and we can actually relate different meanings to different emotions. But speech data are generally the language independent. I mean, if you extract the features from the speech data, those features are language independent, and you have to consider the other aspects of the speech data to learn the emotions and sentiments from the data. Okay, so that is a challenging task, because the way we utter the words in different contexts will be different ways. So what are the emotions encoded in our or embedded in our speech is too challenging to identify. And the integration of the uh, other domains. I was talking about the multimodal LLMs. So all are actually working towards that multimodal LLMs nowadays. Okay, for example, if you want to translate or if you want to uh, answer one question based on an image, so visual question answering. Okay, so you need to learn, you need to have the knowledge of the image processing or computer vision and NLP. Or else if you want to generate some description about a X-ray image or MRI image, then there also you have to combine the image and uh, uh, text data. Or else if you want to identify the sentiments expressed in a movie review posted in YouTube. Okay, so you are going to analyze the video data, you are going to analyze the speech data, you are going to analyze the text data. So you require the people with a different skill set. Okay, speech skill set, image skill set, image processing skill set, and a text processing skill set to deal with that one data. Okay, one video data. So that was the problem with the previous AI approaches. Before this deep learning or transformer era, we had, if you see the rule based approaches, you need people who has the knowledge of the language, you need people who has the programming skill set to implement one model. Okay, the same problem we are facing now. To deal with the multimodal data, we need people with a different skill set. But if there is one model which can do a lot all these tasks by itself, okay, then you require one person who knows how to process the data, how to use this model for our applications. Okay, basically one very good programmer can do all these tasks if you have one model which can learn features from multiple modalities. So that is going to be the next or people have already started doing research in multimodal large language models, but lot of research opportunities are available in multimodal LLMs or multimodal data analysis in the current era. And second, the last one is real-time and interactive NLP. Suppose there is a climate problems like flood comes, okay, or traffic signal management. Okay, if there is a huge heavy traffic in one road, okay, so the algorithm has to send a message to all the people that there is a huge traffic, then you have to take these roads to avoid the traffic congestion. Okay, so those models are basically real-time models. I don't think we have a very accurate real-time NLP models to inform people about the current traffic conditions or current climate conditions. Okay, so you can actually start, if you want to do research, there is one research avenue where you can actually find a lot of research problems. So challenges in natural language processing, the one of the most prominent challenge is ambiguity in the language. So you can find ambiguity everywhere, starting from the meaning of the words, okay, how we interpret the word meaning, how we interpret the sentence meaning, how we understand the meaning beyond the word meaning, okay. So a lot of ambiguities are there in the language. So how do we represent the words by considering the ambiguity into account, okay. So that is a challenging task, okay. So I was talking about the word embedding models in the first slide. The same concept here also I can explain, like the word embedding algorithms that we use nowadays, I don't think the algorithms are able to deal with all sorts of ambiguity in the language. So the algorithms like word2vec, fasttext, the glow, etc., were able to generate only one representation for one word in the entire corpus, okay. So nowadays we have BERT algorithm which can represent, which can generate different representations based on the position information. Okay, so BERT can actually resolve this issue to some extent by considering that positional information for generating the embeddings. But I don't think that actually solves the real problem of this ambiguity in the language. Okay, because there will be words which can be used in different contexts, okay. So if one word appears in a context which is very rarely occurs in the entire corpus, training corpus, then I don't think the algorithm will be able to learn that contextual information very accurately. Then if it is not learning that context accurately, then you may lose that contextual information for generating the embedding. Then the embedding will not carry that contextual information. So a lot of challenges are there related to ambiguity, and one challenge which is related to my PhD work was the preposition sense disambiguation, like identifying the sense of a preposition in a given context. Okay. That time we used machine learning approaches and some word level features and noun level features to identify the meaning of the preposition. But nowadays we have these embedding algorithms which can do better than that for solving the ambiguity. But I don't think it is 100%. We have achieved 100% accuracy in this ambiguity management. So cultural and linguistic variations are there. So we have to deal with the dialects, the way we pronounce the words, phonology, phonetics, all those things we have to consider while developing the model. Because when we translate, when you go to the regional, local places, people will be having different slangs, different dialects. Okay, so they may not be able to understand the meaning of one word that may generate that are generated by the Google Translate or similar translation engines. Okay, we have in Kerala one word that we use in the North Kerala have different meanings. Sometimes the opposite meaning in other places of the Kerala, maybe in southern Kerala or mid Kerala. Okay, that the similar challenges are there in dealing with the words and the word meanings. Then common sense knowledge is another problem. So there will be proverbs, idioms, etc. in languages. So understanding the word meaning or phrase meaning beyond the word meanings is very challenging. Okay, so we have to teach the models about the common sense in the language. Okay, not just the word meanings or phrase wording meanings. We have to teach them how these phrases are actually capture the or represent the contextual information when it is appeared in a given context. Then data quality and quantity are two challenges in natural language processing research, not just in natural language processing, but in all the domains. But the data quantity is not a big problem nowadays because of the availability of the zero shot mechanisms and few shot mechanisms. But data quality is important. The quality data is required to train or fine tune a model. If you don't have the quality data, then your output will be affected by the quality, the data used for training the model. And bias and fairness, I was giving some examples related to bias and fairness in the previous slide. And ethical consideration also, like federated learning is there. Okay, so the data privacy preserving data mining is an important task in natural language processing, because we have to respect, or people have to respect our data, our private data, and we have to respect the way we share the data across the social media or other uh, platforms available in the internet. Then domain specific challenges are there. Generally, all the models are general purpose models. Models in the sense, large language models are general purpose models. It can perform different tasks in different domains. Okay, but if you want to develop a model for legal domain or healthcare domain or some language specific domains, we need more data, more quality data with uh, yeah, more quality data is required for developing the models for some domain specific task. Then resource intensive training is also required because for training a large language model or fine tuning a large language model for different tasks, we require huge amount of computational resources. Okay, many of you have actually come across that kind of problems in the implementation. The RAM that you require for training the model or the GPUs, number of GPUs you require for training the large language models are very, very important. And continual learning is also important. The reason is every day the data is becoming updated in the internet and new data is coming to the internet. So every day we have to update the knowledge by adding new data, fine tune the model by providing new data. Because if you see the older chat GPT model, you can find a warning message, like it can create harmful messages. Okay, when it is used for generating text. Nowadays, you cannot see that message in the home screen of the chat GPT because they have uh, updated the model by using new data. Okay, they believe that the new data is derived from that bias and all those problems, but still they are able to create data, I mean, biased information, or they are able to generate biased content in different cases. Okay, but to avoid all these problems, we have to update the model by providing new good quality data every day, or else you had used the reinforcement learning concept RLHF to update the model by taking the feedback from the users. So again, these are related to what I was talking about in the previous slides. Research avenues in NLP, contextual understanding and common sense reasoning is one avenue where you can actually invest your time and life. Okay, so a lot of challenges are there with respect to this contextual understanding and common sense reasoning in regional languages, not in English. I'm not talking about the English language, but the regional languages, especially our Dravidian languages. Then emotion and sentiment modeling, you can actually combine text and speech domains to capture the emotions, sentiments, and other similar features from the data. Okay, emotions, sentiments, the offensive content in the data or the hate content in the data, and you can also find similar task in the by combining speech and text. Then conversational AI and dialogue systems, a lot of research is happening in that direction. Okay, basically the domain specific models have a lot of importance, like chatbot for medical domain, chatbot for legal domain, chatbot for education domain. So if you can build models for these domains, or if you can build conversational AI or dialogue management systems for some a task, language learning task kind of task, then you can do some research on it. Then cross-model NLP, multi-modal NLP. Okay, by combining, so emotion and sentiment modeling can come in that aspect by combining multiple modalities like images, speech, text, and you can also combine videos to deal with this multi-modal NLP. A lot of research is happening in that direction. Last year, we conducted one competition as part of the EACL conference. That conference is happening now. Today is our session. So I have conducted one multi-model sentiment analysis task. Only one team, I mean, we have received more than 40 registrations, but only one team was ready to submit the result. That shows the challenge in dealing with the multimodal data. Okay, so we need, if you want to process the multimodal data, you need people have these skills: image processing skills, speech processing skills, and text processing skills, or you should be able to use the multimodal models for dealing with these tasks. So that is not an easy task, dealing with the multimodal data. So NLP for low resource languages, I have given some examples or research areas in the last slide. Okay, so low resource in the sense low resource language or low resource domain. In both cases, we have lot of opportunities available. Then NLP for healthcare and medical text. So if you see the application of NLP in healthcare and medical text, the amount of opportunities are immense. Like you can build your own chatbots. There are, I mean, you can learn the concepts. Learn some informations from the doctor's prescriptions. You can actually generate reports for different images, X-ray or MRI images. You can actually, without visiting the doctors, you can actually communicate with the hospital through chatbots. Okay, so a lot of opportunities are there. Or you can actually analyze the, you can actually extract the vital information from the patients and process it and sends those vital information to the doctors, and doctors can process it and send back to the report to the uh, patients or relatives of the patients. So lot of opportunities are there in the NLP for healthcare domain. And common sense and knowledge graphs. So learning the meaning of the proverbs and idioms is going to be too challenging. So yeah. So interpretable and explainable AI in NLP. So all these large language models are kind of black boxes. Okay, so how they are learning all the data or what they are learning is a big question mark. So we need to understand what they are learning, what these models are learning, how these models are learning. So there are papers which has actually explain the learning process in the large language models or basically transformer based applications. So you can utilize those models and you can actually use it in our regional languages. So applying these techniques in our regional language has a lot of significance and research opportunities. Multilingual, cross-lingual NLP. So building multilingual translation models or building cross-lingual or multilingual embedding models has a lot of opportunities available. Then NLP in augmented and virtual reality. That is going to be the next big thing in the NLP research. So industrial applications of NLP, basically healthcare applications. I was talking about some applications in healthcare. Then in finance, you can find the applications of NLP. Finance in the sense you can actually to predict the or to forecast the stock market values. You can actually consider the sentiments of the users when government publishes some policy, then users, the end users or common people will be posting their sentiments in the Twitter or X or Facebook or some other domains. You can actually analyze the sentiments in those texts and predict how this stock market will behave in the coming days. Or else you can apply the algorithms available in transformers. Different transformer based algorithms are there, like autoformer is there for predicting or for forecasting the stock market values for 5 days or 10 days or 1 month time or 1 year time. So it is able to predict the stock market values in the long domain. Then e-commerce and customer service, recommendation systems. Okay, so movie reviews, then sorry, movie suggestions, then product suggestions. In those cases, we can use the uh, NLP cases. Then customer review analysis, basically sentiment analysis, or chatbots for interacting with the customers. Okay, you can find the applications of NLP in those areas. Then content creation. One author, when I attended the one literature festival last year, one author, I'm not going to name that author, he said that he used these AI tools to get the one line for his novels and short stories. Okay, you can use, you can seek the help of these AI tools to write poems, write stories. Okay, when RN was introduced initially, algorithm, I mean, people tried to write the script of one Friends series episode using RNNs. People were able to generate that script that time in 2016 or 17. Okay, now this ChatGPT or Gemini, they can actually create a better version of these scripts very easily. Okay, so if you want, you can use the take the help of these models to generate the contents. People are using these AI models to draw the pictures. Okay, some people are actually selling the pictures created using Midjourney and all. Okay. Then legal and compliance. Actually, I found a lot of issues in related to some uh, when I was doing some registration. Okay, I had a lot of documents with me, so I was not able to understand what is there in the documents. So if I had a tool which can actually give me extract some information from those documents and make me understand that okay, these are the informations available in these documents, then it would be very really helpful for me. Okay, so you can actually create such applications in like legal domains. So if there is a document legal domain, go through the domain and extract the useful informations and provide those to the or make it in a simple way and give to the end users. Social media analysis, very common application. Education domain, you can find basically learning tools. Okay, teaching tools, you can find the application of NLP. Then manufacturing, supply chain monitoring, resume parsing, you can find the application of NLP. So future directions of NLP, basically, it is again moving towards the human level language understanding. Even now, even the large language models are not able to learn all the languages completely. Okay, maybe they are successful with English languages, but they are not successful with our languages. Okay, then multimodal integration, that is going to be the next big thing. And so this ethical responsibility of the NLP models always a big concern in the research domains. Okay, so when we create our data, when we create our model, we have to make sure that it is not biased towards any individual or organization or anything. Okay, it should be free from all the bias and ethical problems. So when we annotate our data, we have to be make sure that very sure that our data is not biased towards anything. Okay. So NLP in augmented and virtual reality. So very less number of papers are coming in that direction. So in the next few years, we can find the boom in NLP in augmented and virtual reality because we can actually interact in real time with that models. Okay, you can expect that kind of models in the coming days. Then continual learning and adaptation. We have to, I mean, every day new data is coming to the internet or new data are uploaded to the internet, and we have to make sure that the models are continually updating their knowledge. Just like us, we are reading papers, we are reading books, we are surfing the internet, and we are updating our knowledge every day. Similar to that, we have to make sure that our models are also updating their models day by day or in a day-to-day basis for the better model, because we are all are using these models for our day-to-day activities, and if these models have any issues that will or that may cause some issues in the society. Okay, so we have to be really careful in that aspect also. Okay, so I think with that, okay, one more point is there beyond text-based communication, like we have to consider the speech and the multimodal the modalities also to deal with the data, and inclusivity. Okay, that is also talking about the I mean, inclusivity can be related to the biases in the data, or it can be related to the languages, because the people try to use English language for training the model. So we had to consider all the languages to build the models, because we need models for our languages also. Basically, in Malayalam, if you consider the Dravid languages, Malayalam and Tamil has some models available, but when we consider the Kannada and Telugu languages, very few models are available for processing these languages. Then emotionally aware AI. So we had to build models like Moxie robot in the future for improving the social skills, improving the mental skills, improving the communication skills. For all these skills, improving all our skills, we can use these kind of tools. Then intelligent personalization, or it also comes along with this emotionally aware AI. So if you have a model which can actually interact with us just like a human being, then that model has to be personalized to each user based on the way we speak to the model. The algorithm will be able should be able to uh, uh, learn our the way of speaking, the vocabulary that we use, the way we construct the sentences. Everything should be learned by the model, and based on that, they have to reply to the users. So with this, I am closing the session, and thank you for your attention. And if you have any questions, I am ready to take up a few questions. Okay, thank you. Thank you for your patient attendance. Thank you.
Thank you so much, Fath, for the enlightening section. Now you can leave for the tea break, and another section will start at 11:10 a.m.